In this video, I'd like to cover some properties of ionic structure. And previously, we talked about ionic bonds, and we said that ionic bonds are formed from metal and a non-metal. So when you have a metal and a non-metal, the resultant bond is ionic bond. Now, ionic bonds normally exhibit giant ionic structures. Now, an ionic compound forms an lattice or giant ionic lattice structure, or rather you can just say giant ionic bond. And it consists of regular arrangement of ions together by held together by strong electrostatic force between oppositely charged ions. Previously, we said that a metal is positively charged while a non-metal is negatively charged in terms of ionic formation. Now, when we have negative and positive charges, we call that type of force an electrostatic force. So when we have those forces interacting together, they result into ionic bonds. Now, an example of an ionic structure or giant ionic structure is sodium chloride, and it forms a cubic structure whereby we have a sodium ion surrounded by chloride ions. In this representation, the red ones are sodium ions while the green ones are chloride ions. Now we have some properties of ionic compound, and one of them is that ionic compounds have very high melting points and boiling points because of large amounts of energy required to break the bonds or the electrostatic forces of attraction. Now, ionic bonds are very strong bonds. It therefore means that when sodium and chloride ions are joined together, there is high energy that is required to break these bonds. Now, when we talk about electrical conductivity, most of the or all the ionic compounds do not conduct electricity in solid state. Why? The ions of sodium and chloride ion, in an example of sodium chloride, they are in fixed position, therefore they cannot conduct electricity. But in liquid or dissolved, in this case it is in a molten state, and in this case it has been surrounded by water molecules. Wherever you're seeing these two small balls and one small ball represents water molecules surrounding the sodium ions and chloride ions. It means that in molten or liquid state and in dissolved state, they can conduct electricity, but in solid state, ionic compounds do not conduct electricity. Here, I have a summary of general properties of giant ionic structure, and one of them is that they are hard and brittle. Now, the exact reason is that ionic bonds or ionic solids are very hard because of the ions are held together by strong forces of attraction. We talked about ionic bonds. Now, they are brittle and thus may be split cleanly or cleaved using a sharp-edged razor. Just like a knife or even a razor blade, you can easily cut off sodium chloride structure. I talked about high melting point and boiling point because of the strong ionic bonds between the two. And finally, we can talk about solubility. They are very soluble in polar solvents. Underline this word, polar solvents. Now, polar solvents are like water molecules. They are polar because they have slightly positive and slightly negative charges. And on the other hand, they are soluble in polar solvents like water, ethanol, and acetone. Now, we have non-polar substances which mostly are organic compounds, like for example methylbenzene. Methylbenzene cannot be, sodium chloride cannot dissolve in methylbenzene, but in water, ethanol, and acetone, they are polar solvents. That is why sodium chloride can dissolve in them, or rather ionic structures can dissolve in them. Now, water contains highly polar molecules, and the positive ends of the polar water molecules are attracted to the negative ions in the crystal, and the negative ends of the water molecules are attracted to the positive ends of the crystal. Remember, we said that the crystal, an example of sodium chloride crystal, contains positively charged sodium ions and negatively charged chloride ions, and therefore there is an attraction between the positive ion in sodium and the negative ion in water, and negative ion in chloride and positive ion in water molecule. Now finally, I have a general property of sodium, some examples of ionic compounds of sodium, beginning from sodium fluoride to sodium iodide, where we can talk about the melting points, we can talk about the electrical conductivity in either solid, molten, or solution form. And that one brings me to the end of this summary, and I hope you are improving in your academics. And don't forget to subscribe and also like the channel, and kindly share it with your friends. Thank you.